Båten brorsan.
Hello, today I received Pi Terminal 7-inch IPS HMI CM4 panel all-in-one module Raspberry Pi computer from Elecrow. The shipment arrived in about a week in a branded box, well protected from mechanical damage. The package contains a 7-inch Pi Terminal with user manual, Wi-Fi antenna, 12 volts 2 ampere adapter, and 3 Phoenix type connectors. First, I would like to describe some of the features and functions of this small but powerful computer. It is equipped with the powerful Raspberry Pi Compute Module 4 as the main control, with excellent real-time performance, and can quickly respond to and process real-time control and monitoring tasks. It has 7-inch display with a resolution of 1024 on 600 pixel and a touchscreen with 5-point capacitive touch. A highlight is the rich industrial interfaces and functional modules, including CAN bus, RS232, RS485 isolated digital input-output, differential input ADC, relay control, etc., which fully meet the communication and control needs with various sensors, actuators and other devices. Communication capability is another highlight of Pi Terminal. It integrates Wi-Fi, BLE and reserves mini PCI Express interfaces for 4G and LoRaWAN. At the same time, it provides gigabit Ethernet to ensure high-speed data transmission and remote monitoring between devices. Pi Terminal supports a rich software ecosystem based on Raspberry Pi and is compatible with the Node-RED programming tool, giving users the ability to easily create and manage IoT applications. Now let's look at the input-output interfaces. RS232 port, next UART communication port, gigabit Ethernet, HDMI output, audio in-out connector, 2 USB-A ports, on-off switch, micro SD card slot, SIM card slot, LED indicators, 4 SMA antenna connectors for LoRaWAN, Wi-Fi, GPS and LTE, 220-pin GPIO, 2 camera slots, another GPIO connector, relay control, DO and DI connector, and CAN RS485 and ADC connector. Now let's briefly look at the inside where the motherboard is located. This is the Raspberry Pi CM4 board. It is cooled by this small fan, relay, speaker and fan connectors, and 2 PCI Express slots in which the LoRa and GPS modules are mounted, which I additionally ordered. This time I want to present you a simple way to make a portable software-defined radio, SDR radio, that would work independently of a PC. For this purpose, besides this panel display, I will also use a cheap RTL-SDR USB dongle. A software-defined radio is a radio communication system that uses software to process various signals, modulation, demodulation, decoding, etc. A typical SDR setup involves an RF front-end connected to a computer that will perform the conversion from digital to analog and vice versa. Because of rapidly developing digital electronics, the capabilities of SDR continue to increase. In this case, the RF front-end is this cheap USB dongle, and the signal processing and visual presentation is the task of this beautiful display module. In one of my previous videos I presented a way to make a similar device like this, but then some hardware work and modifications were needed, and some more advanced knowledge in this area was required to make it. Unlike then, this time making the device requires almost no knowledge in the field of electronics, and the SDR radio works flawlessly and stably. This time I present you one of the possible solutions, which is this box that I specially made for this display module, but also the device can be made without a box so that the USB dongle can be glued directly to the back with double-sided adhesive, and we can use a wireless tuning knob if needed. The complete device is very simple to make and consists of only a few components. Display module, which is the basis of the whole project and whose characteristics I presented at the beginning of the video. Small speaker, rotary encoder, RTL-SDR USB dongle, USB hub, and modified PCB from a cheap PC mouse. The modification consists in desoldering the original miniature rotary encoder and soldering a more robust one in its place. These are all connectors that need to be connected to the display module. This is power supply connector, should be connected here. USB from USB hub. Cooling fan for Raspberry Pi should be connected here. External Wi-Fi antenna. And speaker connector that should be connected here to one of these audio outputs. The small speaker is connected to the appropriate place provided for it on the board of the display module. As you can see, the sides of the display module are open out of the box so that you can easily put for example an SD card or some other external device. On the outside of the box I made a socket for a Wi-Fi antenna, although we don't need it for this project. Now let's dwell a bit on the software part. In fact, it is the software that in this case replaces a huge hardware part on the radio and is also highly adaptable and responsible for the professional characteristics of this relatively cheap radio. As we can see, the display module itself comes with a recorded Raspberry Pi operating system which start with a demo program that describes some of the panel's characteristics. I didn't want to modify this factory preset operating system, so I decided to use another cheap micro SD card to record the whole new setup. This is the factory demo program. To prepare a new operating system, we need a SD card with a size of 32 GB or more. On the SourceForge site, you can find a Raspberry Pi image with huge number of programs from the field of ham radio called Ham Pi, including SDR Radio software that we will use for the needs of this project. Now I will briefly describe the method of preparing the SD card. First, we need to download Balena Etcher software, which serves to flash iOS image to SD cards, and Ham Pi image from the given pages. Next, we install and run the Balena Etcher software. Press flash from file, and we will choose the previously downloaded file. That is Ham Pi image. Now we connect SD card to the card reader and to the USB port of the PC. Press select target, and we can select the micro USB card. Next we press flash and wait for the procedure to finish. With that, the card is ready and we can mount it on the display panel and start it. The operating system starts immediately and no special settings are required. As we can see, all important ham radio applications are pre-installed on it, and we especially interested in SDR software, specifically SDR++ and GQ-RX. GQ-RX is a well-known Unix software, but at least for me, SDR++ is even better thanks to its low hardware equipments, multi-platform support and high similarity to SDR Sharp, which is always a commonly used Windows software. For smooth control, I use this miniature Bluetooth keyboard mouse combination, which fits this device perfectly. I will start with the broadcast FM band because there are many strong active radio stations here, so the possibilities and the way of working with this receiver can be easily presented. After starting the software, the majority of functions can be controlled through the rotary encoder and touchscreen, so there is almost no need for a keyboard and mouse. I will avoid commercial music station for copyright reasons. We can move through the entire display range by touching the screen. Or more sophisticatedly with the rotary encoder. We select the movement step by pressing the appropriate digit where the frequency is displayed.
Është diçka e mrekullueshme. Po më thon shumë gjëra.
We can also use a wireless tuning knob, the making of which I described in one of my previous videos.
Grup në thonjza, dhe se nuk është se ka plane për një rikthim.
The following is a short demonstration of the receiver's capabilities and operation on different wavebands. And finally a short conclusion. First of all, let me tell you that I'm really surprised by the construction, possibilities and stability during operation of this display terminal. I previously had some experience with this type of devices, powered by a Raspberry Pi 3B with 2 GB RAM, but I can comfortably tell you that the difference is incomparable, starting with the robust and quality build, flawless display and touch panel, and most importantly, stable and fast, long-lasting operating without any signs of heating, blocking, lack of power, etc., which were common in my previous project of this kind. And this is just one small project with which I turned this display terminal into a quality SD radio with professional capabilities and features. In the future I will try to describe many more simple ways to use this piece of hardware to build other quality devices.